Hello everyone, welcome back to FMCG. I am your AML consultant Shaunak here, and in this notebook we'll be discussing Plotly. So this video is a part of a data visualization series, and in this video and the video following this we'll be focusing on Plotly. In this particular video we'll be focusing on Plotly level 1. Level 1 will consist of the common charts and plots that Plotly has to offer. So the reason I have named this notebook as solved because I'll be sharing the GitHub link in the description where I'll be keeping the solved and unsolved notebooks. So in the solved I'll be writing the code as well line by line, and in unsolved I will not be writing the code. However, if you refer here, instructions are mentioned, the format is mentioned where you can refer these instructions and write your own code. So that is unsolved notebook is for you to practice, and if you want to refer to the solution or the code that I'm going to write here in this video, that will be in this solved one. So level 1 will consist of these 8 charts or plots, and level 2 will consist of uncommon charts or plots. Uncommon as in they will consist choroplates, then sunburst charts and several others which we do not use that quite often. In this video we'll be focusing on first one will be the histogram, second one is scatter plot, third one is bar chart, fourth one is pie chart, then violin plot, box plot, area plot and line plot. So let's jump right into it. If you don't have Plotly, you can run this command !pip install Plotly. So that will install Plotly in your Jupyter Notebook. So this right now I'm coding in Jupyter Notebook. So Jupyter Notebook is quite popular with people using who are into data analytics and data science. So if you don't have Plotly, you can use !pip install Plotly. Then necessary libraries that I'll be importing is this import warnings and warnings filter warnings ignore. So if we get any warnings, this particular line of code will ignore those warnings. Then from sklearn datasets, I am importing iris dataset. So for demonstration purpose, we are going to make use of iris dataset. Iris dataset is a very widely known dataset, very popular dataset. I'll show you how it appears. Then for data wrangling, we'll be making use of pandas. So we'll load this iris dataset in pandas DataFrame. And for Plotly, we'll be making use of plotly.express and we'll import it as px. So Plotly offers the most common way of plotting graph using Plotly is either using graph object or express. So in this particular scenario, in this notebook we are going to use express, but plotting using Plotly graph is very easy and similar to express. So express takes care of most of the coding APIs, so that's the reason we'll be making use of express, so it will be easier for you to follow. So just know that plotly.express is imported as px. Then for data frame, if you want to see, the data frame will appear like this. First column will be sepal length, second will be sepal width, third will be petal length, fourth will be petal width, and target will be this setosa. And in total there are 3 classes: setosa, versicolor and virginica. And I guess we have in total df.shape. We have in total 150 rows and 5 columns: sepal length, sepal width, petal length, petal width and target. Now first graph that we'll be focusing on is histogram. So for Plotly, plotting the graph is very easy. Just remember there are 3 lines of code that you should write. So first will be fig equal to px dot. This should be followed by the type of graph that you are plotting. So in this particular scenario, first example is for histogram. So px.histogram, and here the parameter that you need to pass is for data frame. So our data frame is df, so I am passing data frame parameter as df, and then x, let's say you want to for our first demonstration, I'll write x as only one attribute. So name of this particular column, it should be a numerical column, sepal length. So let us make use of this sepal length, and then second will be fig dot update layout. Here you can write the title of the graph in title text. Let's say histogram of sepal length, and on x-axis you can write x-axis title. You can say length, and on y-axis title, sorry, there should not be underscore over here, it should be count. And if you want to determine the height and width, you can do that as well. Let's say we pass in height as 300 and width as 600. And the third line that you should write is fig.show. Unless until you pass fig.show, it will not show the graph. So here we have received this histogram for sepal length. What if you want to plot more than one column, more than one array? So you can plot that as well. You just have to pass in the array. So we have plotted sepal length. The next which we can plot is, let's say, sepal width. And just for demonstration purpose, let us plot another one, third one, petal length. So if you see, in total 3 have been plotted. First one is, this is for petal length, the green one is for petal length, the orange one is for sepal width, and the blue one is for sepal length. So this is how you can plot the histograms on top of one another. Now moving on to the next one. Also one more thing, if you see, the title is appearing over here, histogram of sepal length, and x-axis length, where that we have passed over here. I made a typo, it should be length length, and count on y-axis. Yeah, now it is appearing length and count. If you want to download, you can, if you are referring here, you can see the options. This one is for download plot as PNG. Upon clicking it, it will get downloaded to your downloads directory. And next, zoom, pan, box select, lasso select, zoom in, zoom out, auto scale, reset access, and this one, produced with plotly.js. So you have several options over here. The most which I use is to download plot as PNG. Now moving on to the next ones, moving on to scatter plot. The format remains the same, 3 lines of code, fig equal to px.scatter. Then you have to pass in the data frame. Then you have to pass in the numerical column on x-axis and numerical column on y-axis, because scatter plot is usually plotted for 2 numerical values. And you can also pass in the color as well if you want to differentiate the different spots on scatter plot based upon their class name. So in our example, the class name will appear as Setosa, Versicolor, or Virginica. So we will get 3 different colors. So let's do that. Fig equal to px dot scatter, and data frame will be df, and on x we will type, let us take this sepal length and sepal width. On y we take sepal width, and color let us take as target, this one. Then fig dot update layout, then title text, instead of scatter I'll write length versus width, and x axis title as, on x-axis we have taken length, and on y-axis we have taken width. Let us keep width of our graph as let's say 7, and height, it should not be 7, it should be 700, and height should be, let's keep it the same, 700. And then finally fig dot show x-axis title, x-axis title text. Okay, I made a mistake over here. WID, it should be TH. There was a typo. Yeah, and now it is appearing. Let me just reduce the width and height because it is not appearing in my screen properly. Yeah, so if you see, let me just reduce this furthermore and increase this. Yeah, so if you see over here, length versus width, and here if you see, blue color is for Setosa, orange is for versicolor, and green is for virginica. Length versus width, we are getting good scatter plot over here. Then the next plot that we'll be looking at is bar chart. So bar chart is basically, we'll be getting the plot in the form of bars. It can be horizontal, vertical, it can be stacked or unstacked. So the format remains the same. First line of code will be saving the plot in a variable, and it will be px.bar. Data frame will be the first parameter, and then as long as you define the parameter, the order won't matter much. So data frame should be the data frame that we'll be using. On x-axis you have to pass in nominal values. So in our example, nominal values are the ones which are appearing in target. So Setosa, versicolor, virginica, these will be the 3 nominal values that we'll be using. And if you are getting confused between nominal, ordinal and numeric values, I have discussed this in the first video itself. I'll also discuss it quite briefly right now. So nominal values are values which do not have any relation to each other. So in this target collection, in this particular column, so if I make a list out of this target, and in that list we'll be having 3 separate values, Setosa, versicolor and virginica. So these 3 values do not have relation with each other. Setosa doesn't have any relation to versicolor, versicolor doesn't have any relation to virginica. So these are nominal values. If you refer to these 4 columns, sepal length, sepal width, petal length and petal width, these will be interpreted as numeric columns. 5.1, 3.5, 1.4, 0.2. These values, these columns will be interpreted as numeric values. If you are referring to ordinal values, then ordinal values will be numbers, but these values will be ordered either in ascending order or descending order. So these will be ordinal values. The name itself implies that there is some order, ordinal values. Now coming back to our bar chart, so this is a data frame which we have derived from the parent data frame df. So what I have done over here is I have grouped the data frame based upon the target, and I have taken the maximum values. So if you see over here, so for Setosa, maximum values appearing are 5.8, 4.4, 1.9, 0.6. For versicolor it is 7, 3.4, 5.1, 1.8, and virginica 7.9, 3.8, 6.9, 2.5. So let us plot a bar plot. So fig, let us save it in the variable fig px.bar, and here data frame I will be passing it df bar max, this data frame which we have derived. And on x-axis we will be taking the target values. So df bar max dot index, this will give me these values, the target ones. And on y-axis we will be plotting these values 5.8, 4.4, 1.9, 0.6. So basically these columns, all 4 columns. So on Y I'll be passing list of these columns. So to get the list I'll be typing the DataFrame dot columns. So DataFrame dot columns will give me a list of columns in that particular data frame. And on next line I will type fig dot update layout, and title text, that will be the title of our graph. Let's name it bar plot for max values, and on x-axis title, let me just save this. X-axis title we have classes, and on y-axis we have the values, and finally fig dot show. And we have received this bar chart. So let me just quickly define the height and width. Let's put HEI, height as 400 and width as 800. Yeah, so now it is appearing on the screen. And these are by default, the bar charts appear as stacked. So if you don't want them to appear as stacked, we can pass in another parameter. So the name of that parameter, I have mentioned it over here, bar mode equal to group. You have to enter bar mode as group, then you will get unstacked bar charts. So if you see, lengths are appearing over here. For Setosa, these are the max values. For versicolor, these are the max values, and for Virginica, these are the max values. If you want them in a stacked manner, you can just remove this and you will get the bar chart in a stacked manner. Now moving on to pie chart, the only change will be in the first line of code, px.py. Then you send in the data frame, and in names you have to pass in the nominal values, that is Setosa, versicolor and Virginica. This one, the target. Coming back to pie chart, and in the values column you have to pass in the numeric column. So let us plot that. For this particular purpose I have derived another data frame. So what I have done over here is I have grouped our data frame by target, and I have taken mean. In the above example preceding this, here we had taken, for bar charts we had taken the maximum value dot max. For pie chart I am taking the mean value, that is the average, and from that particular data frame I am taking only the petal length. I am ignoring the other 3 numerical columns. So just focus on this particular data frame for plotting pie chart. So fig equal to px.py, data frame will be df underscore py, and then names and values, names will be the target, and values will be petal length. Then fig dot update layout, here title text will be pie chart of petal length, and then fig dot show. So it is giving us a pie chart, and if I want to change its height and width, height equal to 400, because since it is circle it will be plotted in a square format. So I have just passed in only one parameter, height. So if you see, blue is Virginica, orange is versicolor, and green is Setosa. Then violin Violin plot. Violin plot is similar to box plot. So the format remains px.violin, and in that you pass in the data frame. On y you pass in the numerical columns, and you can also get different types of violin plots based upon the nominal column. So label call is nothing but nominal column. Label call is our target column where we have Setosa, Virginica. So let us plot it. Fig equal to px dot violin. In data frame it will be df, and on y-axis we will take all the numerical columns, df dot columns, and then color will be target. First I will not pass in this box equal to true, so I'll be able to tell you what the difference is by keeping box equal to true. And fig dot update layout and title text equal to violin plot. X-axis title, that will be on x-axis we'll be getting call names, that is a column names, and on y-axis title measurements, because on y-axis we'll be plotting the measurements of these different attributes like sepal width, sepal length, petal width, petal length. And let us keep width as 1000 and height, this should be comma, and height as 400. And then fig dot show, and here we have received 4 violin plots. Let us increase height so we get a better view. Yeah, so if you see, we have received violin plot of these 4 attributes, 1, 2, 3 and 4. Sepal length, sepal width, petal length, petal width. It is not appearing that properly because there is wide range in the length of petal width than petal length, so that's the reason. So just for our understanding, I'll plot only the first 2, sepal length and sepal width, instead of all the 4 columns. So here I have to change sepal length, sepal width, so it is appearing. And the width, if you see now, when I am moving the cursor over it, it is also displaying the value as well, that value is changing. And the width and narrowness of the violin plot is based upon the frequency distribution. So where the part is the most thickest, the maximum count is for that particular value. And now if I pass in box as true, we will also get a box over there. So if you see, this box is appearing over here. And here we have the legend. So this is for violin plot. Now violin plot is exactly similar to box plot. So just for demonstration purpose, what I am going to do is I'll copy this code and I am going to make only one change for box plot. I'll replace this violin with box. Okay, so I have to just remove this one box, and now we will be getting box plot of the same thing. So reason for box plot, the difference between violin plot and box plot is basically used to get the median, get interquartile range, maximum and minimum value, and if there are any outliers, we get to see those outliers using box plot. So if you see in this particular case, sepal length, so sepal length is having an outlier. This point is the outlier. In Virginica, value is 4.9. And similarly for sepal width, in this one, purple means setosa. In setosa, we have this outlier where the sepal width is 2.3. So box plot tells us more information about median, interquartile range, and minimum and maximum value and outliers, whereas whereas Violin plot, it gives us information about mean, maximum, and interquartile range along with the frequency distribution in that particular value as in that particular range of values. So the thickness is directly proportional to the number of counts for that particular attribute. That's the difference between Violin plot and box plot. So box plot is also done. The only difference is instead of using px.violin, I have used px.blocks, and I have removed the attribute of box equal to true, which was appearing over here. I have removed that. Rest all the code remains the same. Now moving on to the next one, area plot. The format is px.area, then you pass in the data frame, and then on y-axis you passing the numeric columns. So let us plot, let us save it in fig equal to px.area, and data frame I will be passing is df, and on y we will be passing let us pass all the numerical columns. So df dot columns, and then fig dot update layout, title text, let us give it area plot for 4 columns, and on x-axis title, let us give it observations, because on x-axis it will be from 0 to 150 since we have 150 observations, and on y-axis title it will be the measurement, that is the values corresponding to all these 4 columns will be shown on y-axis, along y-axis, and on x-axis we will be having our observations, that is in our data set we have 150 observations, so it will be as per those observations. Then finally fig dot show, plot like an process wide data in different. Okay, so instead of columns I think I'll need to pass it sepal width, sepal length. Yeah, so I have to pass in differently. The in earlier case where it gave an error, we were also passing the target, so I had to remove that. So this is for sepal width, which is appearing in purple or blue, and in red sepal length is appearing. We can also plot the remaining 2 as well, petal width and petal length. Yeah, so all the 4 are appearing. So if you see observation ranging from 0 to 150, and measurement is as per the measurement that we have in our data set, stacked on top of one another. Blue is petal width, red is petal length, green is petal width, and purple is sepal length. So this is the area chart that we have plotted using the area plot. Now moving on to the next one. The last one is the line plot. So for line plot we have to plot on x-axis the attribute that will be passing on x-axis should be an ordinal property, so it should follow ascending or descending order. So what we will do for our demonstration purpose, we will plot on x-axis the observations ranging from 0 to 150, which is as per our data frame, because we have 150 observations in our data frame. And let us plot the petal length on y-axis. So fig equal to px dot line, and data frame will be our df, and on x-axis it will be list range 150, because we'll take a list from 0 to 149, that is in total 150 values. And on y-axis let us plot petal length, then fig dot update layout, title text equal to line plot for petal length, x-axis title let us give it as observations, and on y-axis title will be petal length measurement. We can also give height and width, height as, let's give it height of 400 and width as 1000, and then finally fig dot show, and we'll get a line plot. So if you see observation 0 to 150 and petal length measurement, let me just check whether we can pass in the color as target. Yeah, so if you see, we have three classes, Setosa, Versicolor and Virginica. So based upon the three classes we can plot the line graph as well, and if you don't want it as per the classes, you can remove this and then directly plot it. So this is how it will appear in a continuous format. So that was the last graph that we'll be discussing in this particular video. So in total, to wind up all the things that we discussed, we saw what Plotly was, and the plots that we discussed were histogram, scatter plot, bar chart, pie chart, violin plot, box plot, area plot and line plot. Now if you want to see the documentation for Plotly, I have mentioned the link over here. Plotly supports wide range of languages, so Python, R, Julia, then JavaScript, all these are supported in Plotly. Also these are just the plots which are used most commonly, which I have included in this level 1 notebook. In the next video we'll be discussing about level 2, where we'll be discussing more sophisticated charts and plots. So do check that one as well if you are interested in data visualization, and if you're also interested in Plotly or Seaborn, I have uploaded those videos as well, and down the line I'll also be uploading video for Altair and Folium. So if you like this video and if you found this helpful, do let me know in the comments, and if you want me or if you have any recommendations for me, you can mention those as well. If you want me to create another video related to Python, data science or machine learning, I can do that as well. Basically I like to utilize my time practicing these skills, so, and also I like to make videos. That's all for this video. This was Shaunak helping you out with Plotly. I hope you found this helpful. If you like this video, give it a thumbs up, and I'll see you in the next video. Thank you.